This is an example of converting a decimal number to binary number, and the examples requires us to convert a number that has a whole part and a fraction part. We have done another example already. This is the second example. So how they are, as we have seen, there are two methods of converting decimal numbers to binary numbers. Method one involves repeated division by 2, and method 2 involves positional weights of the symbols. And when we are converting the fractional part, as we have already seen in the previous example, we multiply, or we do repeated multiplication by 2. For the whole part, the positional weights are weighted with base 2, such that we have 2 to the power 0, 2 to the power 1, all the way going upwards to the power n. And when we consider the fractional part, the method 1 involves repeated multiplication by 2, and method 2 involves positional weights, where we say that we are from the dot point, we increment towards the negative number to base 2. So we start with power minus 1, power minus 2, power minus 3, etc. So in this example, we convert our whole part to start with, in which case we say we can use either method. If we use method 1, we say 20 divided by 2. The first answer is 10, remainder 0. Divided by 2 again is 5, remainder 0. Divided by 2 again is 2, remainder 1. And divide by 2 again, you get 1, remainder 0. Therefore, as we did in the previous example, we start from this value going upwards to the first one. So the number 20 is therefore represented by 1 0, this 1, this 0, 1 0 0, 1 0 0. So this is 20 to base 2, or 20 to base 10 is represented by 1 0 1 0 0 to base 2. And using the other method, which we already know, we can still use the same method, which is the positional weights. We know that the highest multiple of 2 is 16. So we will start by 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power, and 2 to the power 4. This represents 16. Of course, this is 8, blah, blah, blah. So the same method we used, we said 20 minus 16 is equals to 4. So we have used the first one. Then we are going to use the other one that represents 4, which is 2 to the power 2. The others, we give them a 0. And therefore, we are going to have 1, 0, 1 0 0, and this is the same answer that we got using the method 1. So we have done the conversion for the whole part, or the whole number, and we have seen that it is represented by 1 0 1 0 0. Now we do the fractional part, and we can use the two methods again just to confirm that we understand both of them. The first one is that one of multiplication by 2, and we just consider the fractional part alone. So we are going to start with 0.125 times 2 is equals to 250. So the first 0 that we get is the one that we say, the one that goes to the right of the decimal point. So we put the 0 there, then we multiply by 2 again, we get 0.500. This 0 we get here, we add it here, and then we do again, multiply by 2, you get 1.000, and this 1 is the one that we place here, and therefore there is nothing else in the fractional part to multiply. Therefore we end up with this is equivalent to 0.125 in decimal. This is the one represented by base 10. This is in base 2. So that is method 1. And method 2, we just need to know the 0.125 is the one we want to convert from decimal to binary. And therefore we know that the powers in binary are 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3. We want to find the one that represents this number. So the first one is 0.5, which is far bigger than this one. The second one is 0.25, still bigger than this one. The third one is 2 power 3, or 1 over 2 to the power 3. This is equivalent to 1 over 8. This is equivalent to 0.125. And therefore, this is the number that will give us a 1. The others, we are going to give them a 0. And this confirms, so this is in binary. And and this is in decimal. So this is how you convert 0.125 in decimal, which is to base 10, to become 0.001 to base 2,